Welcome back to the channel. In this final rebuild series of this particular engine, the 9A1 MA1 flat 6 3.8 engine, I'm going to finish rebuilding it. In the last video I rebuilt the bottom half, the long block, so this video I'll be putting the cylinder heads on and all the ancillaries, completing that crucial cam timing I know a few people are interested in. I'll go through any questions anyone's thrown up in the last few months where I can as well, and also point out anything interesting during the rebuild and observations. What I do with the engine once it's finished, I haven't decided yet. It's going to be in the position of being a fully A1 refurbished engine. Yeah, I mean, something like that from Porsche would have been £20,000 plus VAT when they used to be available. So yeah, considering I've still got another spare pair of crankcases to repair, haven't decided on that one yet, but yeah, we'll see where we go with that one. But yeah, don't forget to like and subscribe, and let's get to it. Enjoy. So first things to do is put the lower crankcase baffle on, then the oil pump, I believe, and then I need to work out everything else, the pipes and so on, and what orders what is going. So I've cleaned everything up here, quite anal. I've wrapped everything whilst it's waiting in cling film to keep any dust off things. Most of the Torx bolts are called out to be torqued to 13 Newton meters. That seems quite a common Porsche torquing spec. And interestingly, torquing the lower oil pans, they are torqued in a specific order, so I'll show you that when we get to that. And so it goes this way, but if you come up at an extreme angle, and then it drops on. And they're 20mm torque screws to be torqued to 13 Newton meters. The sprocket here that I'm going to screw to the oil pump, that is normally a stretch bolt, and it's saying it's calling in the spec to tighten it to just 5 Newton meters and then give it a 90mm turn and a use only. Silly me, I overlooked that, so I haven't ordered one. That is an MA size. So what I'm going to do is torque that. Most of their Porsche's M8 torque to 33 Newton meters. So I'm going to put some nut lock on that and torque that to 33, rather than wait weeks just for a fresh bolt. Next, oil pump. Incidentally, that's a new seal there. (13 Newton meters for the securing Torx bolt for the oil pump. A new gasket. And a little dielectric grease, never harmed. Sure, a good seal. The gasket never sticking. And there's one other reason I'm a big fan of that dielectric grease, is it deters any moisture coming in and causing any corrosion over the long term. And I have just noticed something that I've forgotten to do actually. There is a heating pipe that needs to be secured first before dropping the oil pan into place. Yes, it's this one, this little blighter here. Obviously you could never get to that otherwise. So there is another pipe there, but I don't think that's going to be a problem just yet. No, very clearly not. I'll come back to that when I fit the water pump. Right, the correct order to torque these up then is specified. It's calling for 13 Newton meters. So I shall follow this sequence. A couple of people have asked in the question, where did I get the service manual from? If you just Google service manual 991.1, you'll see there's a few available on forums like Renlist. I see there's somebody who's popped one there in his Dropbox. But even if you go on eBay, it's possible to buy the one that I'm using. Just put service manual 991.1 in eBay, and there's someone selling that on a CD-ROM as well. Next is this with a new seal, and there are two new seals on this solenoid as well. I believe this is a solenoid to activate a higher oil pressure in sport mode. That has two seals here. There's a running oil channel. I think it was Robert Soul in the last video asked if I'd pre-gapped the piston rings, because they'd noticed in the video I hadn't. And the answer is to that is the Porsche supplied OEM piston rings, incidentally, which are made by Maya, so the pistons. Now they actually come pre-gapped, so there is no adjustment to make on those rings. They are as supplied by Porsche. And yeah, those cylinders are just as they are. There are no such thing as Porsche oversized cylinders or oversized pistons. So yeah, I thought that was a great question. I did actually look at bypassing Porsche and trying to get the the pistons and rings as a kit from Maya. Now, funnily enough, although they do have a part number for that, they do not actually have stock or any plans to manufacture any. So that's a shame. Beautiful. Okay, back to the German sense of humour, talking. The torque order of the oil pans, particularly the upper oil pan, doesn't seem to make any logical sense at all when you look at it, but I followed it to the exact order. Right, that is done. Next up is the cooling on the front, including the water pump and water pump housing. I've got a brand new water pump here to go on as well. Right, new gaskets are on this cross pipe, and all of these components are the ones that have been vapor blasted. And in actual fact, I just thought they looked so nice that what I've actually done is I've put a clear coat over these components and then baked them in the oven to preserve them. It's a high temperature clear coat, bakes on at 200 degrees C at the activate. So yeah, these should be staying shiny for some time. Let's just give those surfaces one last clean with some IPA. Yeah, so as mentioned, that's a brand new water pump there that I pre-fitted to that housing. There are several aftermarket brands available, and that's the German brand Jeber that I've used there from, supplied through Porsche Design 911. It's just a nice thing to do at this stage. You know, you've got a brand new bearing. It's not going to leak. Next, it's these coolant distribution pipes. So new O-ring. I've also purchased a new pulley tensioner wheel that the pulley dampener attaches to, that you'll see me fitting in a moment, from Design 911, another OE match part. I think it was Porsche 914 that asked in my last video what I'd done with the cylinder liners. I guess he may not have seen the very first earlier videos I made, but these crankcases I've used, that I bought the new pistons from, they were nearly new. I managed to purchase them secondhand, but nearly new, and they need a small welding fix to it. So that was featured in some earlier videos. I still have the original damaged crankcase, and yeah, I am looking at doing something with that. So if and when I do, I'll certainly be featuring that in another video. But nevertheless, both the current crankcase there on this engine you see there, and the one that I'm going to repair, I had both of those cryogenically treated prior. So yeah, perhaps I'll do something with that at a later stage. In case you're wondering what that red pipe is on the oil cooler there, housing, that's actually not being used, but that is a spare part of the oil cooler if this particular engine was to be used in a Porsche with, I think it's active suspension management system, where it uses a pump to keep the car on a sort of level playing field, cornering. Those tend to have an additional pump, so this isn't going to be used in this case. I've blanked. This particular bank of the crankcase has plastic blanking inserts that go into the cylinder fixing bolt holes, and I didn't actually show that on this part of the video, but don't worry, I didn't actually miss that, in case anyone has observed that. I did actually go back and drop them. The purpose of the blanking plugs are simply to reduce the size of the what would you call it, the molding of the crankcase itself, because they have to mold those the bolt holes this side slightly wider, so you can actually reach in there with a torque spanner and actually do those bolts up. So for the purposes of speeding this video up, you're not really going to get to see exactly the cylinder head sequence here, but as shown in the above diagram, this is the order that you do the main stretch bolts up. And you start off by doing them all up to 10 Newton meters and then to 50 Newton meters in the shown order. Once that's done, you slacken them all off to take all their tension off, then retension them to 4 Newton meters, then to 12 Newton meters, and then using an angle gauge, the stretch bolts 1, 2, 3, and 4 in the center of the heads, you angle them up to 65 degrees, whilst the outer remaining 4, you then, is it 4? 2, yeah, 4, you torque them to 60 degrees. Then you go back and torque the center 4 by a further 65 degrees, move to the outer ones and torque them to a further 60. So you must do it in that order. The outer torque bolts, the M6s, they're all done up to 13 Newton meters, which you can do before and then after and recheck them right at the end when it's fully torqued. Hope that makes sense. You'll get to see all this again when I do the second bank in any case. So they're the outer 4 I'm working on there. They're getting their 60-degree angle. That one's also 60. And that one's 60. Also 60. And then the inner 4 here, so a further 65 for these. I should imagine why they just get that extra angle is because in the center there is to do with heat expansion, and the gaskets are a kind of multi-play design, so they allow for a bit of movement and expansion as well. So this is the inner still 65. And then back to the outer 60 turn angle on these. Certainly with hindsight, I wish I'd invested in a very expensive torque gauge that actually digitally measures the torque angle as well as the torque itself. It certainly make working on this engine a lot easier. Porsche seem to like torquing a lot of important things to an angle. So those M6 torques on the inner part where the crank case timing chain is, those bolts, they're all to 13 Newton meters. As you may have just seen, I've done them as well. So that's the cylinder head torqued. And a little bit of assembly lube for the camshafts that are going to be dropped on shortly. Right, now that the cylinder heads are correctly torqued up, it's time to tackle the camshaft timing. So let's fit those camshafts. Just initially, engine has been rotated to top dead center. So there is a top dead center mark on the pulley wheel here, marked OT1A, and it's a sort of teardrop shape. There's various points around here. So there's like behind in the casting there's a plug hole. So oops, you can wind it round and then plug that there with a suitable size screwdriver or the correct tool. This nice looking little pin. So that's spot on top dead center. And from there, I shall be setting the timing. Okay, so if you remember from my earlier videos, I did not remove the sprocket on the exhaust camshaft. So now the exhaust camshaft has only one way it can sit in here whilst being flush to all of these valve buckets, and roughly as a guide position, that's with the with the code stamped on this facing upwards. You can see it's just missing all of the valves. Let's not get ahead of ourselves, but the chain tensioner I've removed from this side, so the chain tensioner isn't under its hydraulic compression. So that's going to help. So with that in position goes the inlet cam, and again this has this facing up with its marking horizontal at the back, and in this position it's not trying to actuate any of the valves by pressing on the valve buckets. That's the securing bolt and the cam actuator. Okay, so that is now lined up nicely on the chain guides. So with that in position, I can just drop the actuator down. That should slide on to the camshaft. The camshaft in the correct position. And it does. Okay, so now I need to check both of those relative to the top dead center. So let's just rotate that to top dead center and pop the pin in. So this is the most important cam to get in the right position, and with its tensioner screwed in this side, that's going to probably turn it a little bit this way, and that's what it needs to get to have this horizontal. This is nicely lined up horizontal. And then once that's horizontal, I can put these clamps on and hold that in position whilst I tighten everything down. Okay, so this is my initial positioning, and if I just I manually push that guide in taut, so that's taut, top dead center here, I can just see that this isn't in the correct position. This needs to be, this isn't a cam lobe, nor is that. That's the timing lobes, and they need to be sitting perfectly down when I put my clamp on. So I can see initially that just needs to come across one more tooth. So I'm gonna have to just whip it apart and just move the one tooth that way. So unfortunately that just has to come off again. Just pop that out of the way. So that chain just needs to be back on its guide rail to give me the correct. Okay, yeah, again, this little section here has moved. So with the fettling here, that chain must have just slipped round on the crankshaft one tooth. So let's have one more go at that. Being aware that the chain can slip on the tooth. Pop this back in, all pointing up. It's just a timing mark that doesn't really do anything as far as I can see in the grand scheme of things, because wherever this actuator is located doesn't matter. It's where the cam itself, this bit, is actually located. Okay, that looks a little bit more promising because these two are now pointing down. Well, particularly this one on the exhaust. Looking at the back as well, this is nicely lined up horizontal. Obviously that's going to need to be horizontal too, but that's still free to move at this stage. So the next thing I'm going to do is just fix these camshafts down lightly with the saddles, and then pop the cam timing kit on. So these saddles are marked the inlet E1, E2, E3, the exhaust A1, A2, A3, and the text as you look at the engine. I'll come around here. So if I'm looking at this front ways on, if you imagine it's mounted flat, the text must be flat, so you can read it horizontally from this angle, if that makes sense. You see how the text is lined up, A1, 2 and 3. Okay, I'm not going to torque these properly at this stage. I'm just going to do them up lightly to about 5 Newton meters. A bit more assembly lube there. And then this front saddle also has the integral chain guide. Then I'm just going to pop the chain tensioner piston in. So that's this thing here. You can actually fill this thing up with water, with oil. Simply give it a couple of pumps. So that's useful. That pre-primes it during assembly. So that goes in here. I believe it's a 17mm socket. I'm just going to do this up till I can feel some pressure, and that's just moved just a fraction, but it's still looking good. So I'm not going to do that up fully yet. I'm going to get the timing saddle on. So these clip over these two bits I mentioned earlier that aren't actually the cam lobes themselves. And then you just need to torque the top up here, which clamps them securely. And I have read in the Porsche service manual that you torque this down to 8 Newton meters. So that's what I shall do. Don't put too much pressure on it. Obviously it's pushing that pressure straight onto the camshafts, which are quite delicate. It's 8 Newton meters. So this is absolutely bob on. I think I'm good to go. I'm just going to put a little bit more pressure on the chain tensioner, but just hand pressure. It's quite taut because it's this location here on this cam controller is the critical fixing that I'm doing. Right, so tightening this up there is a Porsche procedure, and that is to torque it to 30 Newton meters and then 90 degrees from there on. So that should be simple enough to work out. So this nut here has to be held in situ whilst tightening the Torx bolt. That's 30, so it needs a further 90 from there. Okay, I have got my old faithful angle gauge out for that. When torquing this bolt, it's critical you hold that nut exactly straight and don't put any stress on the camshaft. There we go, 90 degrees. Okay, the proof in the pudding will be to take this saddle off and give the engine a couple of revolutions and make sure everything comes back. And it is. So now I can torque that chain tensioner up correctly. So the torque on these saddles is a small torque. I think it's 5 or 10 Newton meters. I'll just check that. Hang on, don't take my word for it. And then an angle again. Let's just make sure everything's got some torque on it before I do that chain tensioner up, because that chain tensioner will then put some stress on those cams. The torque for the chain tensioner is 18 Newton meters, quite a bit. Just going to give this one more rotation just to make sure I'm absolutely happy with the alignment. Say one rotation, it's actually 2 rotations on the crankshaft to give the camshaft a single rotation. Got a little bit far. An extra one. There we go. A quick eyelash, and everything is spot on. These are facing up. These are identical vertical positions, and then the telltale bit is on the back of these camshafts. These two perfectly horizontal. So that's the timing done. Yep, the deal with these camshaft saddles is to torque them to 5 Newton meters, and then with the angle gauge 50 degrees. Anyway, 50 degrees it is. And that's just to mention, torquing from the centre, then the forward, then the rear cam carriers, and then lastly the timing chain cam carrier. Right, next up is the cam covers, and of course there's a torque sequence to them, and they are all torqued to 13 Newton meters. So just before then, last up, I'll just pop a tiny drop more on the cam lobes, a good measure of assembly lube, so they've got lots of nice sticky oil on them when this engine gets its first firing. And just give that an extra clean for good measure. Now the mating surface with IPA. Okay, I've pre-greased them already with dielectric grease. Mike Ormond on my last video, I think he pointed out that I hadn't balance the conrods correctly. He was right. There is a special conrod balancing tool to do that job properly. Now, the everything there, the conrods and pistons were Porsche OEM, so they were initially in spec, and I was just interested in getting the reciprocal balancing spot on, which is more important in a horizontal opposing engine. But to do the reciprocal balancing correctly, yes, you do need a conrod balancing tool. So thanks for pointing that out, Mike. So 1, 2, 3, 4, and 18, 19, 20, 20 exactly. And recheck 1, 2, 3, and 4. And they haven't moved, so that's good. Next, the top of the crankcase breather, new gaskets with some dielectric on, and 13 Newton meters. Next up, the fuel pump. Again, new seal here. I've actually given this a clean up, but I didn't actually video it. It has a little peg here that you absolutely must get lined up to the exhaust camshaft. So do ensure you get that right, because it will be a big problem if that's wrong. Thirteen Newton meters again. In addition, there is also a cover here. And lastly, there is a coolant hose here, which I believe, from memory, goes off to the expansion bottle. Okay, so that's bank 1 done. Hey, having flipped the engine over, it's the same deal this side. Head gasket and head on. The design of this head gasket is quite interesting. It's made of 3 layers, and the reason is for that to allow for plenty of movement and expansion as the block heats up and cools down. Attached a piece of wire here to be able to pull the timing chain up easily. One last clean. So the bottom left of the picture there, you can see the air oil separator, which I didn't video, but yeah, that's a new addition as well to the engine, and makes sense to replace it at this stage. Okay, talking cylinder head in the order as follows. Looking at this way round, it's 1, 2, 3, 4, 5, 6, 7, 8. The initial talking to 10. Eight. Now same order again, but to 50 Newton meters. Once again, this is the torquing order that Porsche give for these stretch bolts. Next up, there are 1, 2, 3, 4, 5, 6 securing bolts, M25s, plus this one additional long one on the inside the crankcase here. A 25mm M25, 25mm long. And needless to say, they are tightened to 13 Newton meters. Okay, so with that torque to 50, it's a case of now undoing them to 0 again. Now torquing them back to 4. With them all at 4, now take them to 12. Andrew Slater in the last video, I believe, asked how much the cryogenic treatment was for the crankcases. So for 2 crankcases the size of the MA1 engine, that was £400 a set, so I had 2 done. And the vapor blasting, that was approximately £300 to have all that done. I did actually look into having ice blasting done, actually, and that was incredibly expensive. I don't think it would quite have been as good as the vapor blasting either, to say the least. It's just surprising how expensive things can be. Desmond asked, what am I doing different this time in this engine? And of course, the cryogenic treatment, the idea is that that's removed and eliminated any stresses in the crankcases that are always there from day one. So hopefully that will stop any crankcase distortion and likelihood of cold seizure. That's the hope, anyway. Next, to fit the last chain tensioner, and I have a brand new one here to prep. So I will fill that with fresh oil. It has a little hole here to suck in the oil. Surprising how much air actually comes out of it. Okay, that's good. So I'm not going to torque that up just yet. Camshafts next. Just something unusual that I've noticed on these hydraulic valve tappets here, on this side of the head, which I'm just going to look into. So these tappets depress nicely on a spring, but these 2 here are solid. Certainly their outers move, and the outer move on here, but before the outer moves on here, the inner moves a considerable amount. But these 2 in the center cylinder seem to be solid. It's coming down to the outsides moving, but the inside here is just not depressing. So I'm going to look into that. A bit confused. Okay, right, little update on these hydraulic valve tappets. Thanks to the forum, the Porsche Engine Gurus on Facebook, several people came back and told me what the cause of this is. And it's simply because this particular set was still full of oil, simply because they probably hadn't experienced compression from the camshaft when the engine was sitting idle. So what I did is I popped this camshaft back on, rotated it manually to force these under maximum compression, and left them half an hour. Came back, took it apart, and lo and behold, here we are, now behaving in a similar manner. So under compression, apparently that forces any oil left in here out of these holes. And going one step further, there are issues where these things can become dirty and clogged. Another extreme reason why you'd be wanting to change your oil far more often than the crazy 2-year, 20,000 mile interval that Porsche stipulate on many of these. That's just insane. Yeah, because the galleries in here are so small. Yeah, it's not really going to take a lot of bad oil to cause a blockage in there. But yeah, it is possible that they block, carbonize, so on and so forth. in high mileage engines and block altogether. Clearly not the case here. So another worry out the way, I can get on and continue to retime this side of the engine. Okay, right, with that little valve tappet issue, a little scare out of the way, and I'm pleased about that because before I found out, I did look up the cost, and they're £220 each. Yeah, they don't need replacing. Although it is possible to dismantle and service the issue that I need to go through. But anyway, on to the last part of the cam timing. Just a couple of things. I've been through the Porsche service manual and it didn't make a lot of sense to me, but the main reason is because it was all geared around assuming that the exhaust timing sprocket was loose. So it kind of assumed that you were assembling it and then timing both. That's why it didn't really make a lot of sense. But this is a bit different to the inlet cam in that it doesn't have this nut around the outside. The inlet cam, where are we here, is fixed with this long bolt and this large nut, which you can hold this nut. You'll see me do it a bit. You hold that nut fast and then torque it up with a 90-degree turn with a Torx bar. But you only have the torque here, and this sprocket has to be held in place by that special tool, which I showed in a previous video, which I was scratching, wondering what it was for and how it would be used, but that's what it's used for, apparently. And just one other thing as well, in that engine dismantling video, you might recall I used this valve timing saddle here when I was actually dismantling the inlet cam to take the timing chain off. Now, again, you don't need to do that. You just need to get the engine at top dead center. So, and then ensure that none of the cams are depressed on these tappets, so there's no torsion. So if one side is depressed, the other won't be. And then you rotate it a further turn and it swaps places. Yeah, of course you can just use that large spanner and Torx to just undo it. You don't then need that timing tool. So dismantling doesn't really require any specialist tools at all, which is good to know. Okay, right, so on with the timing. So the last part of the timing was done on bank 1, so I'm doing bank 2. Now, it's absolutely crucial that you turn the engine a full rotation more before putting these cams in and timing them. I can't emphasize this enough. You must absolutely have to give it another full rotation. And that's because for one rotation of the camshafts, the engine rotates twice. Makes sense because there's 2 cylinders. But if I did not rotate this and went ahead and timed this side identical to bank 1 side, the engine's just not going to function at all. It's just going to be very, very bad. So you must rotate this one whole revolution. So I will do that now before continuing with the timing on this second bank. Can't emphasize that enough. That would be absolutely tragic if you did not do that. For absolute completeness, what you can do once the timing's complete on both banks is just slowly rotate the crankshaft, and as you go, look at every exhaust port, which you can clearly see, or inlet port, use your choice, and just jot down each valve that you see physically opening as you go slowly, cylinder by cylinder, which particular cylinder comes up and in what order. and then that should follow the firing order of the engine. So as you write the sequence down, you should end up with a sequence of numbers of cylinder 1, then 6, then 2, then 4, then 3, then 5, then 1, then 6, then 2, and etc. etc. Yeah, just for peace of mind, because of course, if you did get one of these banks 180 degrees out, there's just no way this engine's going to work. It's just not going to fire. It's not going to run. It's not going to cause any physical damage, but you'll end up taking the engine out and stripping it apart again, which would be an absolute disaster. Okay, right, so we just need to correctly torque up the bearing saddles now. So there is actually an order to do these here as well, which is basically the center one, 1, 2, then the one towards the controller, 3, 4, then the end one, same this side, and then the saddle right up against the controller and sprocket last. Yeah, so important to torque those camshaft carriers correctly, because there are no camshaft bearings, so they're absolutely relying on a particular engineering clearance that's been put into the casting from the moment it's been manufactured. So worth emphasising that. Time to fit the cam covers. Same deal as before on bank 1. New gasket seals, of course. $20 to be torqued there to 13 Newton meters. Oh, and it did say check the first 4 again. Next up is the crankcase breather. New O-ring on that. Next up is the vacuum pump. Here's the vacuum pump, which I've cleaned up, resprayed, put new seals on. Incidentally, this bizarre thing here pumps or trickles a little bit of oil through here, which I suppose keeps it lubricated, and then it seeps back out into the crankcase. Now there is a keyway in here, which absolutely must be carefully lined up. Vacuum hose. Just for safekeeping, when this engine finally does go back in, I'll just pop there's a new set of exhaust gaskets there so they don't get lost or damaged. Right, with the engine finished, I've just straightened it up. It's time to put some of the ancillaries on, so I put a brand new idler here, got a new drive belt to go, but obviously this engine has no electrics, so that won't be hooked up. Put a brand new starter motor on this because I want to turn the thing over independently with oil in it, get the oil pressure up. So yeah, just got to do the injectors next. So I went through the injectors in a previous video, I believe, and I have 5 refurbished ones. If you recall, one I had to damage to actually remove it, so I've got a brand new replacement. So I've got 6 good injectors. And it's quite interesting, actually. I have discovered since, because I've got new seals to go on these injectors here, this bit PTFE seal that goes at the bottom here, would you believe it, there's actually a special tool there to compress the PTFE that you're supposed to leave over the injectors for 1 minute, and that apparently that takes it down to the correct size before putting it in. So that's some interesting information there. I don't know if you can see that. But of course, I did not do that, and I haven't had any issues at all with the engine that's currently in service that I replaced them. I simply use some dielectric grease. But yeah, just some interesting information there. Right, here we go. Yeah, it's quite interesting. Just a quick eyelash through the service manual parts that I actually use. I mean, the service manual's over 5,000 pages, so I was only looking at small sections. But on the assembly and disassembly of the engine, I've counted over 28 specialist Porsche tools that they recommend to use. So that's incredible. I've never known a manufacturer have so many specialist tools. I wonder whether that's why so many mechanics steer so clear. Give these engines a barge pole because with so many specialist tools they're telling you to use. That would be tens of thousands of pounds of investment. So it does make you think. Why some people think these are black magic or something to work on. So this is the 3 sets of fuel injectors on their accompanying fuel rails being secured in. And next, to feed through and secure the fuel pipes themselves to those rails and to the fuel pump, high pressure fuel pump that is. Next up, the lower sections, the first sections of the intake manifolds being attached here, of course, all with new seals. And incidentally, I've also replaced the vacuum actuators on them, as they're all valve operated. It's quite a cheap thing to do for those. But if any one of those were to fail, they're nearly impossible to access without tearing the top half of the engine apart once it's in the car, which wouldn't be a pleasant job. Incidentally, I sourced them through BMW rather than Porsche, as they were several times less expensive, but same item. Well, that's this engine just about complete now. So I hope you enjoyed the video. Like and subscribe. Not sure where I'll go from here. This engine's ready to be fitted, but I certainly won't be doing the fitting during the end of this winter. It'll be later in the year. So like and subscribe, and catch you on the next one. Goodbye for now.